In this video, we are going to calculate the difference quotient. So what the difference quotient is was derived in a different video, so you may want to go ahead and watch that first. But I say that because you should come in this video with the knowledge that the difference quotient is defined as f of x plus h minus f of x all over h. And so what we're going to do that is we're going to calculate this difference quotient for the given function. In this case, f of x is 2x plus 5. So what we're going to do first is we need to figure out what is f of x plus h. And let's kind of be color coded here because I want us to be able to keep this stuff separate. F of x plus h. And so what we do in that case is to find f of x plus h, we're taking our given function and we're going to say if f of x is 2x plus 5, well then f of x plus h is going to be just anywhere in the original function where you see an x, you're going to replace with an x plus h. Okay? And so if I come back up here, the f of x plus h is what I have shown in blue, and it's going to go right there. And then what I have shown in red is just our f of x function, and it's going to go right there. And then we're going to do a little bit of algebra to simplify. So let's just substitute in everything that we know. Okay? So I'm going to do f of x plus h. And I'm going to subtract f of x, but you got to be careful, we're subtracting the whole thing, so I'm going to use parentheses, and that's going to be all over h. Okay? Now let's do some simplifying. I'm going to start by distributing right there. So I have 2x plus 2h plus 5. I'm also going to distribute that negative there to make that minus 2x minus 5, and that's all over h. And then we've got a little bit of simplification to do. It looks like I have a positive 2x and a negative 2x. Those are going to add to 0. It looks like I have a 5 and a negative 5. That's going to add to 0. So what we're left with is 2h divided by h. I'm only left with this in our denominator. So h over h, that just divides to 1, and it's going to leave you with a 2. So without going too much into why you need to know this for calculus, we just need to know that for this function, the difference quotient is 2. Now, let's do another example. In this one, we're going to do the difference quotient for this quadratic function. So what I would encourage you to do is maybe pause the video, try this on your own, and then hit play and see if you can do it. But we know that the difference quotient is defined as f of x plus h. Then we're going to subtract f of x. And then that's all over h. So we know that, I'm going to kind of write over here, we know that f of x is just going to be our normal 2x squared minus x. So nothing crazy there. But then f of x plus h, we're going to have to do a little algebra here in a little bit with this. That means anywhere we see an x in the original function, we're going to replace it with an x plus h. So we have 2x plus h squared minus x plus h. And that's going to make some somewhat gross algebra here in a minute. So let's kind of set up our difference quotient. We're going to go f of x plus h. So here's f of x plus h. Then we're going to subtract our f of x. And then we're going to put that all over h. Okay? Now, time to do some math. This x plus h squared, we need to simplify that. So I'm going to kind of come over here and I'll work in green. But x plus h squared is the same thing as x plus h times x plus h. And you have to distribute or FOIL or whatever you want to call it. So we're going to have x squared plus xh plus hx, which is really the same thing, plus h squared. And then once I combine those like terms, we have this. So I have 2, and then this stuff right here, we came over here and did all the math, and it ended up being this. And then I can distribute my negative. I'm just going to do a little bit of simplification at a time. Minus x minus h. And then we can distribute this negative as well. Minus 2x squared plus x squared. And don't forget, this is all over h. Now it looks like there's a little bit more distribution we can do right here with this 2 that's out in front. So we now have 2x squared plus 4xh plus h squared. And then I'm just going to copy down all the rest of this. And then we need to divide by h. All right, let's see what cancels. Hopefully, a lot of stuff. But let's see. It looks like, oh no. Either I messed up or we don't have a lot of stuff canceling. But what I see is let's combine some like terms then. 2x squared. Oh, there we go. Those cancels. 2x squared and negative 2x squared cancels. So our only quadratic term with x is x squared, and I'll write it there. Then we have, looks like none of the rest of these combine. So I have plus 4xh plus h squared minus x minus h. Okay? So I'm distributing this negative right here, and it's going to be minus 2x squared plus x. And keep in mind that's all over h still. And then let's distribute this 2 in our next step. So we have 2x squared plus 4xh plus 2h squared. And then I'm just going to copy down the rest of these values, minus x minus h, and then minus 2x squared minus x, or excuse me, plus x, all over h. Now I'm hoping a lot of this stuff cancels, so let's see what happens. I see a positive x and a negative x, those will cancel. Or add to 0, I should say. I see a 2x squared and a negative 2x squared. Those will cancel. And so it looks like what I'm left with is I'm left with 2h squared plus 4xh minus h all over h. So what's great about this is we have an h in each of the 3 terms in our numerator. So I can cancel an h out of each of those terms. So this h in the denominator will cancel with one of those h's and leave us with 2h. The 4xh has an h that will cancel with this h in the denominator and leave us with 4x. And then h over h would leave us with 1. So this value right here is what your difference quotient would be for this function. Once again, we're not going so much into why this is important or why you need to know it for later. For now, we're just saying find the difference quotient for this given function, and basically what you're doing is you're forcing that function into this formula right here, and then in this case doing a whole lot of algebra to get to your answer.